Today we are going to be solving linear systems by graphing. A system of two linear equations in two variables, x and y, consists of two equations in the following form. Ax plus by equals c and dx plus ey equals f. Notice that the x and y terms are on one side and the constant term is by itself. A solution to a system of linear equations is going to be the ordered pair x, y that satisfies both of the original equations. So to start with example 1, we're going to decide is 2, -1 a solution of the system of linear equations below. So taking that the x value is equal to 2 and the y value is equal to -1, I'm going to plug it into both equations and see if it gives me a true statement. So in the first equation, I have -1 times my x value plus 3 times the y value equals -5. So we get -2 minus 3 is equal to -5, which gives me the statement -5 is equal to -5. This is a true statement, so 2, -1 is a solution of the first equation. We also want to check, is it a solution of the second equation? So I'm going to use the same ordered pair, plugging in 2 for x and -1 for y. And I'm going to simplify to see if I get a true statement. So I get 6 minus 2, which leaves me with 4 is equal to 4, which is a true statement. So I can say that yes, 2, -1 is a solution to the equation. Next, we're going to look at solving a linear system by graphing. In order to do this, we need to graph both equations on the same coordinate plane. To do this, we're going to rewrite them in slope-intercept form, y equals mx plus b, or you can graph them using x and y intercept. Then we're going to find the point that they intersect and check our solution by substituting it into both of the original equations, just like we did with example number 1. So to start, I'm going to solve the top equation for y. So if I subtract x from both sides, I get -2y is equal to -x plus 4. Then I'm going to divide everything by -2 to get the equation y is equal to 1/2 x minus 2. Then I can go ahead and graph this, and I have a slope-intercept of -2 and a slope of 1/2, which means I'm going up 1 over 2, up 1 over 2. And I'm going to continue this pattern until I have enough points to connect. It's really important that you use a straight edge when you're drawing in these lines because the intersection point needs to be exact. So here's our first line for our first equation. Then I'm going to solve the second equation by subtracting x from both sides to get y is equal to -x plus 4, which I'm going to graph by starting at a +4 and using the slope -1, so we go down 1, right 1, down 1, right 1. And I'm again going to continue that pattern until I have several points that I can connect. Again, we want to make sure that we're connecting them using a straight edge because that intersection point needs to be exact. So it appears that the two lines intersect at this point, which is the ordered pair 4, 0. And we can check whether or not this is in fact a solution by plugging 4, 0 into both equations. And I can plug them either into the original equations or the ones in slope-intercept form. So if I plug it into the original, the first one simplifies to give me 4 equals 4. So that works out as a solution. The second equation is 4 plus 0 is equal to 4, which also leaves me with a true statement, which means the point 4 comma 0 is my solution. Please try example 3 on your own. We will talk about it tomorrow in class. The second page talks about how many solutions does a system of equations have. If the lines representing a system of equations intersect, the equation has exactly one point in common, so the system has exactly one solution, demonstrated with the first image below. They intersect at one point, so they have one solution. If the lines representing the equations are the same line, the system has an infinite number of points in common, so it has an infinite number of solutions, pictured in the second image below. And the third type is if the two lines are parallel, they have no points in common, so the system has no solution. So because the two lines have the same slope, they will never meet, therefore they have no solution. If we look at example 4, it once again wants us to solve the solution or solve the system by graphing, and we're going to determine how many solutions it has. So the first thing we need to do is solve the equations for y. So in the first equation, I'm going to need to multiply everything by 2 to get y by itself. So we get y is equal to 5x minus 6 as our first equation that we're going to be graphing. The second equation we're going to get by adding 10x to both sides. So we're going to get 2y is equal to 10x plus 8. Then we are going to divide everything by 2 to get y is equal to 5x plus 4. So I'm going to start by graphing the line that was in blue. So I'm starting at -6, which is my y-intercept, and I'm following the slope, which tells me to go up 5 over 1, up 5 over 1, and I'm going to continue that pattern until I have enough points to graph. Again, I want to make sure that I'm using a straight edge to connect my points, which is hard for me to do on the tablet here, but you should be able to do it on your paper. Next, in red, I'm starting at a y-intercept of 4, and we're going to follow our slope, which tells us again to go up 5 over 1. And I can add a few going in the other direction here to make it easier for me to connect my points. Once again, we want to try our best to make a straight line here. It should be easier for you guys. You can use a ruler or the edge of another piece of paper or your ID to help you. Alright, so it's hard for me to make a perfectly straight line, but you should be able to see from this that they do not intersect. Therefore, they have no solution.